All right, let's solve. Log of x plus log of x minus 3 equals 1. Well, I need to get this where it's log equals a number. So, how can I combine those two logarithms?
I don't remember.
Okay, I know it's been a while at the weekend. But remember, what makes you add? Multiply. So I can combine those two by multiplying what we're taking the logs of. So I'm going to write down my log and my base, which I don't have a base written. So what base is that? 10. Good. Of the x times x minus 3.
Wait, what?
And it's equal to 1.
Why is it all?
All right, so let's go ahead and let's just multiply what's in the parentheses. So we're going to get log of, what's x times x? And x times negative 3? Good. Now I've simplified everything inside the parenthesis. What can I do to work this out then? No, it's not a difference of squares. If I factor it, I'm going to go backwards, okay? So it is factorable, but then that'll give me that x times x minus 3. So remember, when you get stuck in one form, go to the other, right? We're in log and we're stuck, so let's go to exponential form. So what is my base on this one? You already told me. What did you tell me it was? 10. What is in the place of my x? Good. The x squared minus 3x. And what's in the place of the y? So I'm going to come over here on the right and change it to exponential. So I have my b to the y equals x. All right, so we've got this set up. Now let's work this part out. What's 10 to the first? So 10 is equal to x squared minus 3x. How can I solve for x when I have an x squared and an x term? We're going to have to factor. In order to factor, I need my equation set equal to 0. So let's move the 10 over. Now, do you remember your rules for factoring? What was our first step? Greatest common factor. Do we have a greatest common factor there on the right? No. All right. Second step was count the number of terms. How many terms are there? 3. So that was simple or alien? Simple. So open your two parentheses. Remember, your first terms have to multiply to be x squared, which are x and x. And my last two numbers have to multiply to the end, so multiply to 10, and then read it backwards. Subtract to 3, which are bigger number first, bring down that first sign. And then negative 5 times what kind of 2 gives us that negative 10. And remember, this is still equal to 0. Then what do we do? Right, set them each equal to 0 and solve. So x minus 5 equals 0 and x plus 2 equals 0. So let's solve both of these for x. But because our problem started out with a logarithm, what do we have to do to our answers? We have to check them, right? So we're going to do a quick little check. So I'm going to check when x equals 5. So I have log of 5 plus log of 5 minus 3. I don't have to worry about the 1. It doesn't have a log, right? I just want to make sure that we're not taking the logarithm of 0 or a negative number. Well, log of 5, that's okay. It's just 5, right? And what's 5 minus 3? So can I take log of 2? Yeah, so 5 is good to go. So 5 is definitely one of our answers.
Would you just put x equals 5?
Yes. No, just put x equals 5. That's one of your solutions. All right, so then let's check when x is negative 2. So I have log of negative 2 plus log of negative 2 minus 3. So let's check the first one. We have log of negative 2. Can I take the log of negative 2? No, it can't be negative. So that means the negative 2 does not work. It was an extraneous solution, and our only solution then is our x equals 5. So I don't know if you just want to box it there, if you want to write it real big so you'll know that that is your actual solution.